Swayam Prabha, free DTH channel for education.
Now we are going to discuss two particular equations. One is called Legendre equation, another is called Bessel's equation. Both these equations are having plenty of applications in the engineering point of view. So what are like the Bessel the Legendre one? So we are going to get some kind of Legendre polynomial, which is one of the important concept in the spherical harmonics, where you are going to use this Legendre polynomial. For example, whoever is studying this geotechnical engineering, for these people, this is very important. They are going to use this Legendre polynomial for finding the signals from the earth, etc. Okay, they are going to use this kind of technique to find the values of some of the coefficients of equations in the geotechnical engineering problem, like inverse problems, etc. will be solving. So in that you are going to use this one. So Legendre equation is going to be useful over there, where you are going to use the spherical harmonics. So what is the spherical harmonics? What is the Legendre equation? So is that we have 1 minus x square into y double dash minus 2xy dash plus n into n plus 1 into y equal to 0. This is called the Legendre equation. Okay, this equation is called Legendre equation, which is one of the most important ODE in physics and many of the engineering things. So this equation contains a parameter called n. Okay, n is there in this equation, and then you are going to call that as a family. Therefore, it is not a single PD; it is a family of PD. Whenever you change the n, you are going to get different ODEs are going to come. Therefore, this is called the family of ODEs. And any solution of this equation is called Legendre function. Okay, so it has you can clearly see that this has two singular points. One is x equal to 1, another is x equal to minus 1. In both cases, you can see that p of x is going to become like p of x is not analytic, and again q of x is not analytic. Therefore, this is going to become like a singular point, and you can see that it's a regular singular point. If I substitute over here, so that is easy one. You can see that, and x equal to 0, which is analytic. Okay, x equal to 0, both p of x and q of x are analytic, so we don't worry about that. Now, what we are going to do is that we are going to find the solution for this one at x equal to 0. Therefore, my equation is going to become like summation am into x power m. Okay, I'm going to find the power series solution, not the Frobenius method solution. I'm going to find the power series solution only. Okay, y equal to summation am into x power m. I'm going to at x equal to 0. Okay, so here what I'm going to do, I'm going to do the similar kind of thing. Okay, so where I'm going to use the power series method which we have used. So that is going to become like I'm going to use this one 1 minus x square into y double dash. Okay, the same logic whatever we used over there, we are going to use it over here. Okay, so therefore this is going to become like I am going to use this one 1 minus x square. Therefore this is going to become like summation m equal to 2 to infinity m into m minus 1 into am into x power m minus 2 is going to come. Okay, minus minus summation m equal to 2 to infinity m into m minus 1 into am into x power m is going to come because x square is there, minus 2 into summation m equal to 1 to infinity am into m into am into x power m is going to come because x is there, that is going to come, plus n into n plus 1 into summation m equal to 0 to infinity am into x power m is going to come equal to 0. So I can simplify this further. Okay, I can write this one. So wherever okay, now what I'm going to do, I'm going to push this. So m equal to 0 to infinity, I'm going to push. Therefore, this is going to become like m plus 2 into wherever m is there. Here m should be going to m plus 2. Okay, m plus 2. Then it is going to become like this one. M plus 1 into am plus 2 into x power m minus this is as it is. Okay, summation m equal to 2 to infinity m into m minus 1 into am into x power m minus 2 into this is as it is, summation m equal to 1 to infinity m into am into x power m. Again, this is as it is, n into n plus 1 into summation m equal to 0 to infinity am into x power m equal to 0. Okay, so only this one I got changed. Now what I am going to do, I am going to simplify this further. Okay, so I am going to start m equal to 2. So if I want to start m equal to 2, this is going to be like 2 into 1 into a2 in a2 in there is x power 0, therefore nothing is there. Here 3 into next one 3 into 2 into a3 into x is going to come, therefore this is going to become like m equal to 2. Now here this is as it is, I am not going to touch this, this is as it is, and here I am going to take first one term only, therefore this is going to become like 2 into m is 1, therefore 1 is going to be there, and then this is going to become like a1 and x is going to be there, therefore a1 x is going to be there, and the next term I am going to get n into n plus 1 into a0 is going to be there, and n into n plus 1 into a1 into x is going to be there. Therefore, if I collect that one, this is going to become like 2 to infinity, this is going to become like 2 to infinity, and this is going to become like 2 to infinity. Okay, so this is there. So if I want to write this one again, okay, so then this is going to become like plus, I am going to have, so remaining term, so this we will compare first. Okay, so these are all going to be 0. So in this case, first we will compare this. Okay, let us compare this one first. Okay, so in this case, what I am going to have, I am going to compare constant terms. So a2 is there, and n plus 1 into a0 is there. Okay, so equal to n into minus n into n plus 1 into a0. Okay, therefore a2 is going to become like minus n into n plus 1 into a0 by 2 is going to come. Now a3 is going to become like, okay, so if I compare this one, 6a3 is going to come. 6a3 is equal to minus n into n plus 1 into a0 is a1 is there, and another a1 is here, therefore that is going to become like plus 2 here. Okay, plus 2 into a1. Okay, therefore this is going to become like a3 is going to become like minus n into n plus 1 into plus 2 into a1 is going sorry, by 6 into a1 is going to come. Okay, what I have to compare the remaining thing. So if I compare the remaining thing, this is going to become like m into m plus 2 into m plus 2 into, so remaining term if I compare m plus 2 into m plus 1 into am plus m into m minus 1 into, okay, here minus is there, and then I have here minus am. Okay, so am is going to be there everywhere, so minus 2 plus 2m here, minus n into n plus 1, okay, here minus into am is going to come. Okay, this is the relation for that. Therefore what we are going to get, am plus 2 is going to become like m into m minus 1 into plus 2m minus n into n plus 1 divided by m plus 2 into m plus 1 is going to come. So if I simplify this further, so this is going to become like minus m square minus m minus 2m plus m is going to come. So m square minus m plus 2m, therefore this is going to become like m square plus m. That I can write as m into m plus 1, okay, plus n into n plus 1 I can write it, okay, divided by m plus 2 into m plus 1 is going to come. And minus is there, okay, minus n into n plus 1 is going to come. So this one I can write it as, okay, m square plus m square plus m plus m, okay, m square plus m minus m square minus n I can write it, okay, divided by m plus 2 into m plus 1. So here I can write it as m minus n into m plus n, okay, again minus m minus plus m minus n I can write it, okay. So if I take m minus n common here, so this is going to become like m plus 2 into m plus 1, okay. So if I take m minus n common here, that is going to become like that equation I can write it as, okay, I'm just going to write it over here, that is going to become like m minus n. If I take it out, that is going to become like m plus n plus 1 divided by m plus 2 into m plus 1 is going to come. Okay, if I simplify this one. So here I have everywhere am is there, so here am, here am, here am, here am, and here am. Okay, therefore what I got this relation am plus 2 equal to m minus n into m plus n plus 1 divided by m plus 2 into m plus 1 into am is going to come. n minus m here. Okay, minus n minus m I have written. Therefore, that is the reason I am telling that. Okay, both are same. M minus n into m plus n plus 1 or n minus m into n plus n minus of n minus m into n plus n plus 1. Both are same. Okay, so therefore now if we find a2, so from here you can see that if a2 I have to put m equal to 0. So if I put m equal to 0, this is going to become like a2 and minus n plus 1 and m is 0, therefore 2 into 1, therefore 2 is going to come into a naught is going to come. Similarly, if I put a3 will simplify and see whether it is going to be satisfied. So this one I can write it as minus of n square. So I can write it as minus n square minus n plus 2 divided by 6 is going to come. This I can write as minus of n square minus n minus 2 plus n minus 2 divided by 6 is going to come. This I can write it as n minus 1 into n minus n plus 2 divided by 6 I can write it. Minus is there. Therefore, I can write this as 1 minus n into n plus 2 by 6 I can write it. Let us see. If I put m equal to 1, this is going to become like 1 minus n. This is going to become like n plus 2. And this is going to become like 3 into 2, 6 into this is going to become like a1 is there. Here also a1 is there. Okay, a1. So same thing is going to come. So it is 2. Now you can see that a2 is this one, a4 is going to become like you can substitute m equal to 2. So therefore you are going to get n minus 2, n plus 3, etc. is going to come. This is going to relation you are going to get. So therefore similarly you can get a3 is going to be this one, 1 minus n into or n minus 1 into n plus 2. So in general I am going to write this one as, okay, so I'll erase the rest. 2 equal to n minus m. Okay, I'm going to put minus here. Okay, same thing, m plus n plus 1 divided by m plus 2 into m plus 1 into am is going to come. So therefore you can put m equal to 0. If you put m equal to 0, then this is going to become like a2 is equal to minus n into, okay, n plus 1 into m plus 2 into m is 0. Okay, m equal to 0. So therefore this is going to become like 2 into a naught is going to come. M equal to 1. Okay, it is going to become like, I am putting m equal to 1 here. M equal to 1. Then this is going to become like a3 is equal to minus n minus 1 n plus 2 divided by 3 into 2. So 3 into 2 into a1 is going to come. If m equal to 2, this is going to become like a4. A4 is going to become like minus n minus 2 n plus 3 divided by 2 I am putting. So 4 into 3 into a2 is going to come. And this is going to become like m equal to 3. So in this case, it is going to become like a5. A5 is going to become like, if I put 3, this is going to become like minus n minus 3. And this is going to become like n plus 4. Okay, divided by m equal to 3. Therefore, this is going to become like 5 into 4 is going to come. So if I simplify this further, so a4 is going to become like minus n minus 2 into n plus 3 divided by 4 into 3 into minus n into n plus 1, okay, minus n into n plus 1 divided by 2 into a naught is going to come. Therefore, this I can write it as, this one I am going to write this way, n plus 3, okay, n plus 1 minus is going to add is here, and n and then n minus 2 divided by 4 factorial is going to come. Similarly, here a5 can be written as n minus 3. Okay, I'm going to write this as n plus 4, n plus 2, or I write it in the reverse direction. Okay, or I write it in the reverse direction here also, like n minus 2 into n plus 1 into n plus 3. Okay, so descending to I'm writing in the reverse order. Okay, so it is going to become like again 4 factorial, and here again same thing. I'm going to write it like n minus 3, n minus 1 into n plus 2 into n plus 4 divided by 5 factorial is going to come. Okay, so you can easily guess that if I write a6 you can easily guess that a6 is going to be n minus 4, okay, n minus 2, n plus 1, n plus 3 divided by 6 factorial is going to come. Similarly, you can guess a7 here. A7 is going to become like n minus 2, n plus 3. Here one more term is going to come, n plus 5 has to come. Okay, so here it is going to become like n minus 3, okay, n minus 5, I can guess n minus 5, n minus 3, n minus 1, n plus 2, n plus 4, n plus 6 divided by 7 factorial is equal to. Okay, these are the things you can guess it easy. Therefore, what you can write, you can write, so this is going to be one solution, this is going to be one solution, this is going to be odd even term, this is going to be odd term, therefore both are going to be independent. So you can write y equal to a naught into, you can write, so everywhere a naught is there, therefore I am going to write 1 minus, this is going to become like n into n plus 1 by 2 into x square, okay, because odd term, and then I have this term plus n minus 2 into n plus 1 into n plus 3 divided by 4 factorial into x power 4 minus, so here minus would come because minus and plus is going to alternate, here also minus is going to come, so therefore here it is going to become like n minus 4, n minus 2, n into n plus 1 into n plus 3 into, okay, n plus 5 divided by 6 factorial is going to come, okay. Similarly, second one, so this is y1, y2 can be written as a1 into is there, so x minus, then I have here x power 6 is there, okay, plus etc. is going to, okay. So here x minus, you are going to get n minus 1, n plus 2 divided by 3 factorial, okay, into a1, so it is going to be x cube plus n minus 3 into n minus 1 into n plus 2 into n plus 1 divided by 5 factorial into x power 5, okay, minus n minus 5 into n minus 3 into n minus 1 into n plus 2 into n plus 4 into n plus 6 divided by 7 factorial into x power 7 is going to come. Okay, so this is the relation you are going to get. Now we are going for the next one. Okay, so therefore you can take a naught plus y1x plus a2 y2x is also the general solution of the Legendre equation. So this series converges for mod x less than 1. Okay, this series is going to converge for mod x less than 1. Since the power of y1 and y2 are different, we can say that we are two independent solutions are found. So according to the theorem, we can get maximum only 2 independent solutions. So that is going to be that. Now you can see that, okay, if n from here you can see that, okay, observe this one, when n equal to m, this is going to become 0. Okay, when n is equal to m, this is going to become 0. All after that, everything is going to become 0. So you are not going to get any terms after that. Okay, so n equal to m, you are going to get 0 term for one thing. For another thing, you may not get. Okay, so for example, m equal to suppose n is odd number. Okay, and when m is reaching that odd number, then this is going to become 0. So you are not, everything is going to cancel. Suppose n is an even number. So in that case, the series is going to exist. One is going to be a polynomial, another is going to be a solution. So one is going to be a polynomial, another is going to be a series. Okay, one solution will be always a polynomial, another solution is going to be always a series solution is going to come. Okay, let us see that. So let us see that. Now what I am going to do, I am going to choose. Okay, I am going to choose an equal to 1 by 2 power n into n 2 power n factorial into 2 power n into n factorial goes to. Okay, we got to choose my a naught. Okay, usually we used to choose a naught. Now what I am going to choose is that for each one you are going to get different an is going to come. Therefore, I am going to choose an such that this is going to be there. Okay, why I am choosing an? Let me tell you. See, once I am keeping here a m plus 2 equal to, okay, this is going to become like n minus m minus n plus n plus 1 divided by m plus 2 into m plus 1 is going to come. Okay, so if it is reaching, you are going to get n plus 2 term is going to come. That is going to become like you are going to put over here n minus m, you are going to get, okay, n minus m, that is going to become like 0. So this is going to vanish. Okay, an is going to be so if you are choosing an plus 2, so that is, suppose I write am, so am can be written as, okay, m plus 2 into m plus 1 divided by n minus m, okay, minus m plus 1 can be written into m plus 2 is there. So if I write this as am, okay, minus 2, am minus 2, then this is going to become like, I got to put wherever m is there, I got to put m minus 2. Okay, so if I put m minus 2, this is going to become like wherever m is there, m minus 2 you got to put, therefore this is going to become like minus m. Okay, minus m is going to come, m minus 2, so minus 2 cancel, and then this is going to become like m minus 2, therefore this is going to become like m minus 1. Okay, and here it is going to become like n minus m minus 2, m plus 2. Okay, and here it is going to become like n plus m is there, so m minus 2, so m minus 1 is there. Okay, this is going to be there. Okay, into a n is going to be there. A m is going to be there. Okay, this is going to be there. A m minus 2 is equal to a m is going to be there. Similarly, if I find a m, okay, so now if I put m equal to n here, suppose if I put m equal to n here, that what is it going to come? This is going to become like a m minus 2 equal to minus n into n minus 1 divided by m equal to n I am keeping, therefore this is going to become like m is, wherever m is there, that I am to replace, therefore this is going to become like 2. Okay, n and m cancel, and this is going to become like n, and this is going to become like, so this is going to become like 2, and this is going to become like 2 into n minus 1 is going to come. Okay, into a n is going to come. Now suppose I choose, okay, choose a n equal to 2n factorial divided by 2 power n into n factorial whole square. So in this case, what is it going to come? This is going to become like minus, okay, so I'm going to become minus n into n minus 1 divided by 2 into 2n minus 1 into, I'm going to use this one, 2n factorial divided by 2 power n into n factorial whole square is going to come. Okay, therefore this is going to become like, I can write this as equal to n in minus n into n minus 1 into 2n into 2n minus 1 into 2n minus 2 factorial divided by 2 into 2n minus 1 into 2 power n into n factorial. N factorial I am going to write as n into n minus 1 factorial. Okay, one term, another one n into n minus 1 into n minus 2 factorial I am going to write. Okay, therefore 2 cancel, n cancel, not this n cancel. Okay, n cancel, n minus 1 cancel, 2n minus 1 cancel. Therefore you are going to get 2n minus 2 factorial divided by 2 power n into n minus 1 factorial into n minus 2 factorial is going to come. Now next one, suppose I put m equal to n minus 2, m equal to n minus 2. So in this case a n minus 4 is going to come, wherever m is there you replace n minus 2, therefore this is going to become like minus n minus 2, okay, minus n minus 3, okay, n minus 2 I am keeping, so n minus 3 divided by n minus m is n minus 2, so n cancel, and that is going to become like plus 2, so that is going to become like 4, n cancel, so 4 is going to come here. Okay, 4 is going to come here, and this is going to become like 2n minus 3 is going to come. 2n minus 3 is going to come. Into, I have to use this one. Okay, into an minus 2 is going to come. An minus 2 is going to come. Therefore, this I can write it as minus n minus 2 into n minus 3 into, I can write this one as 2n minus 2 factorial, okay, divided by 4 into 2n minus 3 into, I can write this one 2 power n into, okay, 2 power n into n minus 1 factorial into n minus 2 factorial, n minus 1 factorial into n minus 2 factorial. Okay, so this I can again I can write it as minus n minus 2 n minus 3. Okay, this I am going to write it as 2n minus 2 into 2n minus 3 into 2n minus 4 factorial, okay, divided by 4 into 2n minus 3 into 2 power n into n minus 1 into n minus 2 into n minus 3 factorial, okay, into again n minus 2 into n minus 3 into n minus 4 factorial is going to come. Okay, now I am going to cancel some of the term. So what I am going to cancel? So n minus 2 cancel. Okay, n minus 2 cancel. N minus 3 cancel. Okay, and 2n minus 3, 2n minus 3 cancel. Here I have 2n minus 2, therefore that I can register 2 into n minus 1, therefore this is going to get cancelled. Okay. Okay, so then I can take this n minus 2, this one, therefore that is going to become like n minus 2 factorial. And here 1, 2, 1, 2, okay, and 1, 4, here 2 is going to become. Therefore this is going to become like here minus was there. There was there is a minus over here also, I think. Okay, minus is there here. So therefore this is going to become like plus. Okay, this is going to become like a plus here. Okay, no minus here. Once I substitute here, it will become plus here. Therefore, what I'm going to have, I'm going to have in the numerator, I'm going to have 2n minus 4 factorial divided by here 2 power n into 2 into n minus 2 factorial. Okay, n minus 2 into n minus 3, therefore n minus 2 factorial, n minus 4 factorial is going to come. So in general, if I write an minus 2m, an minus 2m is going to become like wherever it is that 2n minus 2m is going to come. Okay, you can see that when n equal to 2, you are going to get 2. When n equal to 4, when here 4 is there. Therefore, if I put 2m, this is going to become like 2m into factorial divided by, I'm going to get next one 2 power n. And here you can see that, okay, whenever there is a, here if it is 2, then this is 1 factorial. It is 2 into 2, 2 factorial, 2 factorial is going to come here. 2, I can write as 2 factorial. Next one, you can see that it is going to become 6 factorial. So therefore, this is going to become like m factorial, okay, into here, whenever it is 2, whenever it is 2 into 2, so this one I can write as, for example, this one I can write as a into n minus 2 into 1, and this one I can write as a into n minus 2 into 2, I can write it, okay, so 2m. So here you can see that this is going to become like n minus m factorial, okay, and this is going to become like n minus 2m factorial. This is what going to come. Okay, so this is nothing but your series is going to come. Now what you are going to do is that you are going to write your Pn of x. Okay, Pn of x is going to be like this. Okay, Pn of x is going to form a sequence like this. Okay, what is going to come? Let us write. I'm going to take the series. I'm going to take the polynomial Pn of x. Okay, Pn of x is going to be defined this way. Pn of x is nothing but summation n equal to m equal to 0 to n by 2, okay, means if it is a odd number, you got to take n plus 1 by 2. If it is an even number, just divide by and then take it. And then here it is going to become like a n minus 2m into x power n minus 2m is going to come. Okay, so that is going to be like summation m equal to 0 to n by 2. Okay, into I'm going to substitute it over here. So therefore, this is going to become like minus 1 power m. So here I missed the minus 1 power m. It should be there because minus and plus is alternating. Into x 2n minus 2m factorial divided by 2 power n into m factorial into n minus m factorial into n minus 2m factorial into x power n minus 2m is good. This is called the Legendre polynomial. This polynomial is called the Legendre polynomial. Okay, and one more thing. So you have this equation 1 minus x square y double dash, okay, plus minus 2x y dash plus n into n plus 1 into y equal to 0. This can be written as 1 minus x square y dash whole dash plus n into n plus 1 into y. We can write it. Okay. So from here we can observe these things. Okay, p naught of x. Okay, p naught of x is going to be. You can observe that this is going to be 1, and p1 of x is going to become like x. Okay, so all terms, even terms, you can write it separately. Okay, and p2 of x is going to become like, you can see that. Okay, you can substitute and then you can see that this is going to become like half into 3x square minus 1. Okay, similarly p3 of x you can write it. p3 of x is going to become like x cube term is going to come 1 by 2 5x cube minus 3x. Similarly p4, p5, p6, p7 you can find it. Okay, so similarly you can find all these terms. Now next one, so p2n of x. Suppose I put p2n of x. So in this case, what is going to come? So minus 1 power m. Okay, so minus 1 power m here, and then we have p2n. Therefore, this is going to become like simply n, and this will become like 4n, and this will become like 2n minus 2m, and this will become like 2n minus m factorial, and this is going to become like 2n minus 2m factorial. Okay. Similarly, you can find the p2n plus 1 of x also in the similar. So this is another. So for the we can see that if y2 is always producing a polynomial, okay, in this case you can see that y2 here what is going to have when n is equal to when n is equal to r, okay, when n is equal to r, for example n is equal to 1, in that case what is going to come, the first term is second term is going to become a polynomial, okay, and only x is going to survive, remaining term is going to vanish, whereas y1 is going to become like a series. Now if n equal to even, for example if you put n equal to 2, then this is going to become like 1 minus 2 into 2 3 into x square by 2 factorial plus third term onwards it is becoming 0, because n equal to 2 you are going to put third term onwards it is going to become 0. Whereas if you are putting r term, second is going to y2 is going to become 0 when you are putting r term. When you are putting n equal to even, first term is going to become like polynomial. Okay, so this is going to happen in this case. Okay, there's some more properties. Okay, this is the properties are there. So Pn of minus 1x you can prove it minus 1 power n into Pn of x you can prove it. Pn of minus 1 you can prove it minus 1 power n. P2n plus 1 of 0 you can prove it like P2n dash of 0 and P2n plus 1 double dash, all these things equal to 0 at 0, that you can prove. And P2n of 0 you can prove it like minus 1 power n into these are some of the properties 1 into 3 into 5 etc. 2n minus 1 divided by 2 4 6 into 2n. Similarly, P2n plus 1 of 0 you can prove this way. Pn dash of 1 also you can prove it like n into n plus 1 by 2. And Pn dash of minus 1, once again you can prove. These are some of the properties which you can see. Okay, some of the properties which we have here. Okay, and again some more properties. Okay, Legendre equation is orthogonal polynomial, means minus 1 to 1. Pn into Pm dx is going to become like 0 if n equal to m, and 2 by 2n plus 1 if n equal to m. Okay, this is orthogonal you can prove. And also you can prove that Qn of x, which is called the Legendre polynomial of second kind. So that also you can prove it like Qn of x equal to 1 by 2 into Pn of x into ln of 1 plus x by 1 minus x, you can prove it. And Q naught of x, and these are all some of the properties of Pn and Q1. Okay, so this you can prove. Thank you.